So previously, we were talking about some good shit. It was about rational exponents. So this is rational exponents and radicals. This is R7 and R8. I don't know which one's which. They changed the numbers on me. I have not gone through and changed my lecture notes yet. Oh, Sway, do you mind muting yourself for a little bit? Unless you have a question.
Oh, sorry about that. Sorry about that.
There we go. Cool. If you have a question, feel free to speak up. But
yeah. Sorry, I forgot to mute myself.
Awesome. All right, so we're not going to go over showing how they all work again or doing examples. But as a quick reminder, we add exponents when they're multiplied. And we get, in this case, we would get A0, and that equals 1. We can take negative exponents and move them to the other side of the fraction and make them positive exponents. So this is another way to show that equals 1. We had division. When we divide exponents, this becomes subtraction like that. So a to the m over a to the n becomes a to the m minus n. And we did some examples with that. And then we started talking about the rational exponents. So a to the m over n, when the division is actually in the exponent. This is the same thing as saying a to the m times 1 over n, or a to the 1 over n times m. So I'm changing the order a little bit. When we have exponents multiplied, it means they're coming in this form, where they have an exponent outside the parentheses. A to the m is just a to the m. The 1 to the n, 1 over n power means take a radical root with the index at n. So if I do that here, I have the nth root of a. And then I have to the mth power. And these are all a to the m over n.
Excuse me, can you go a little bit up? Because I cannot see the... Yeah, that's fine, that's fine. Just let me take a picture, thank you. I'm done. Thank you.
Okay. All right, so let's just look at some examples, see how this works. This is where we left off. I didn't do any examples with you. Let's look at some examples. I'm going to write 81 to the 3/4 power. What this means is I'm going to take the 4th root of 81 cubed. That's what that translates into on radical signs. But I don't think that's the way your best way of going about it. Another way of looking at this is 81 is 9 squared, and I can put the 3/4 on the outside. And I can factor that even more. 9 times 9 becomes 3 times 3 times 3 times 3. So I could really write that as 3 to the 4th power inside there times 3 to the 4th out here. So we can do this, convert to multiplication, like multiply those together. 4 times 3 fourths. The 4s cancel, and I'm left with 3 to the 3rd power, which is 21 or 27. All right, let's take a look at another one. We'll start it in a different shape. We will have the square root of 25 cubed. $25 is 5 squared. And so I'm going to just replace that part right there. So oftentimes you won't even see the 2 out front. It'll just look like this. I'm going to multiply that 2 and 3 together just to show you another ways to get this. At this point, recognize that the square root sign means multiply the exponent by 1/2. And 6 times 1/2 is 3. So I've got 5 to the 3rd power, which is 125. Another option you have is to rewrite this in exponent form right away. This is 25 to the 3/2. And then do what I did up above. Write that as 5 squared times 3/2. And we get 5 to the 2 times 3/2. And you see that'll get you 5 cubed. So there's a couple ways of doing this. You don't have to be great at all of them, but hopefully you get a little understanding of how each thing works. So depending on how you see it. Give me a second. You guys ready for more? Does anyone need this up longer? If you do, say something. All right. All right, all right, all right. Let's kick this up a notch. I've got -4 to the 5/2. anytime you see a negative sign with the exponent, if the negative sign isn't inside parentheses, it's not part of the thing to the exponent. This is the same thing as negative and then 4 to the 5/2 like that. So we can take a couple of approaches. I think having an exponent form and working with fractions is easier. I'm going to write this 4 as 2 times 2, which is 2 squared. So I can multiply the exponents and get 2 to the 5th power, which is 32. 2, 4, 8, 16, 32, yeah. Yeah.
I just have a question. So how did we?
Shit, there's a negative there.
Oh, okay. Never mind.
Is that what you're gonna ask?
Yeah.
Yeah. I fucked that up. That whole talk about it doesn't hit the negative sign, and then I dumped the negative sign. That should be negative 32. Thank you. So I'm going to show you now, some people don't like working with fractions, and I know why. Fractions. I generally teach fuck fractions, get rid of them as fast as you can. So another way of going about doing this is I'm going to write this. I'm going to treat this as break it into the radical thing. I'm going to have 4 to the 5th power. And like you wouldn't see the 2. They normally don't show the index out there if it's a 2. So I've got 4 to the 5th power, but this is 2 squared. And so this is really 2 squared times 2 squared times 2 squared times 2 squared times 2 squared. So knowing that this is a square root, since this is a square root, and these are perfect squares, this might be easier to show you something I don't think I showed you already. I can rewrite this as, got my negative out there, but I can break it up. As long as these are just multiplication signs, I can make these different square roots, all multiplied together. And a square root and the square cancels. So it just leaves behind the base, leaves base. And the base here is the 2. So the square root and the square cancel, leaves behind a 2. And it does that on each of them. When you multiply that all up, you get negative 32. But I wouldn't write all that work. I wanted to show you how that works. That works. These two are the same thing. So the way I would look at it is if you like using the radical form, when you have them all multiplied together, for every square that you have that has the exact index on that thing on the outside, just pull out one of the numbers. I'll give you another example of this, like this. I'm going to write, we're going to work with x to the 7/3, and we want to rewrite this. So this is the cube root of x to the 7th power. I didn't give myself a lot of room. I'll just fucking right here. Cube root of x to the 7. What I'm going to do is I'm going to take that 7 and I'm just going to keep peeling off a 3. So if I take 3 away from the 7, I've got 4. I can take another 3 away, and I'm left with just x to the 1st power. You might like this method, because subtracting numbers is pretty fucking easy. So the idea here is I went 7 minus 3, and I pulled out a 3 here. That gives me a 4. I did 4 minus 3. I pulled out the 3 there. That gives me a 1. I can't pull out another 3, so that's just my exponent right there. And now, every one that has an index that matches the exponent, I can pull out. And they are multiplied together on the outside. And whatever doesn't get pulled out stays inside. So this is x squared times the cube root of x. And you can have the multiplication symbol there if you want. You'll notice a couple things. A lot of people just do radical signs like that. I don't like it like that. The things that I do a little bit differently is I make this ledge stick out a little bit longer. And I bring this thing down, I make it do a corner here. The idea of this little ledge is if I have, or better yet, like that, I can't tell, is this x cubed times square root of x, or is this x times cube root of x? Without that little ledge, it's a little hard to tell. So that's why I like the little ledge. It makes it easier to identify that this 3 goes with the root. It is not an exponent on the x. You might find that helpful. No falling asleep. Bring squid ball. Squid ball. Okay, any questions so far? Does anyone need this up longer? When we have an exponent, if the denominator is even, we don't want negatives inside for real numbers. Another way of rewriting this is the square root of -4 cubed. And we don't want negative numbers inside of radicals that are even. We will address this later on when we have negative signs inside of even radicals. We get complex numbers. That's the I that you might have seen. But we'll do that in a later section. It shouldn't show up in any of your homework yet. If the exponent has an odd base, an odd denominator, sorry. Like -27 to the 2/3. This actually is okay. This is okay. This is -27 cube root squared. And I can write -27 as -3 times -3 times -3. So I can write this as the cube root of -3 cubed squared. And so to take that further, we got a 3 on the outside of our index. We got a 3 for our exponent, which means I can just pull out the base. And I still have that parentheses with the square outside. -3 times -3 is +9. I think the radical signs are the hardest way to work with this stuff. Exponents with fractions are easier. And they take up less space. Because once you really understand fractions, they are not complicated. They really aren't. So let's just make a quick summary of the rules. We have a to the m times a to the n equals a to the mn. We'll call that rule 1. If I have that to a power, a to the m times a to the n, and I raise that to, let's say, like a p, we have to distribute the p. Or, that looks funny. this becomes a to the m plus n to the p. Plus np, and that's how those two equal each other. I wrote mn like a jackass. That's m plus n. Fucking it up already. The one that does do the multiplication is, I'll change colors so it shows up a little bit easier. A to the, a to the m and then to the n. That's where the exponents are multiplied. As a reminder, negative exponents flip over. Let's put all of our rules together, because this applies to any of these m, n, and p can be fractions. Finally, we could have that same thing with a p outside. This is a to the mp over a to the np, which is a to the mp minus np, or m minus n times p, which you could do from there. Any of those combinations work. So let's just apply them. Let's apply them to some things that have fractions in them. The first thing I'm going to do is deal with the stuff on top. I can treat that as 18 to the 1/2 plus 7/2. And when I add 1/2 and 7/2, I get 8/2, which is really just 4. So I have 18 to the 4th power over 18 to the 3rd power. And so I can do the subtract exponents. And I get 18 to the 1st power, which is just 18. Let's put out one there for you guys to try. Leave those rules up on the screen when you guys give that a try. In 30 seconds. Might be a little tricky. I'm going to start by moving the 16 to the bottom as 16 to the 3/4 on bottom. And then I'm going to write this as 100 to the 1/2 cubed over 16 to the 1/4 cubed. And then the cubes go together. I can do this, put the cube as one big thing. I'm going to rewrite this. This is the square root of 100. I think that's a little easier to see than leaving it as a fraction. This one, I'm going to rewrite 16. 16 is 4 squared, which is 2 squared, which is 2 to the 4th. So I've got 2 to the 4th power and then a 1/4. Square root of 100 is 10. And the 4 and the 1/4 multiply together to make 1. So this is 1, or 2 to the 1st power. So I've got 10 divided by 2 is 5. I've got 5 cubed. 5 cubed is 125. Okay, let's take a look at another. We got 4x to the 3/4 times 5x to the 2/5. We want to simplify that.
I'm sorry, just the one on top, which one is the result of the one on top?
The 125.
Okay. Thank you.
Okay, so the idea here is to do the constants or the coefficients separate from these. This is 4 times 5. And then I have x to the 3/4 times x to the 2/5. And here we need to add fractions. Or add the exponents, I should say. So that might be worth looking at on the side a little bit. I've got 3/4 plus 2/5. I'm just going to take the opposite denominator and multiply by it. So this will get 4 times 4, and this will get 5 times 5. And I get 15 over 20 plus 8 over 20 is 23 over 20. So that becomes 20x to the 23 over 20. If we wanted to write this as a radical, I think showing how it is a radical when you're starting with fractions is kind of handy. I'm going to rewrite this as a mixed fraction, a mixed number. As a mixed number, that is 1 and 3/20. You could leave this as the answer. That's good. I just want to illustrate some more ideas. Mixed numbers really mean 1 and 3/20 is 1 plus 3/20. And when we have fraction or numbers added together in exponents, what that meant is we literally, before that, we had them like this. And finally, I can rewrite this as a root that's got a 20 base with x cubed on the inside. We could have done that earlier when we did x to the 7/3 and I showed you writing it out as x cubed and x cubed. I can write this as x to the 2 and 1/3, which is x squared times x to the 1/3. So x squared cube root of x.
Those are just different results, or like, I mean, like all of them are the same.
Well, these two are two different problems. This stuff is the same.
Okay, so all of them, like that one, like the one that is inside the square is the same than the last one.
Yeah, we did x to the 7/3 earlier. Let's see.
Yeah.
Well, we did it like this, and I wrote it as the radical like this, and we pulled out x cubed and x cubed.
Yeah.
It's the same idea, working with it as a fraction form.
Okay, so they are the same.
Yeah.
Okay.
All right, let's take a look at something else. Keep going down this rabbit hole. Let me give you guys a couple to do. We're going to do y to the 3/7 times y to the 4/7 minus 5y to the 11/7. So hopefully you remember when we have stuff outside of parentheses and there's a plus or minus, we distribute. This becomes y to the 3/7 times y to the 4/7 minus y to the 3/7 times 5y to the 11/7. And now with these multiplied together, we can add exponents. I'll move the 5 out front. Which gives me y to the 7/7 minus 5y to the 14/7, which is y minus 5y squared. Let's kick it up a notch, because we're all about kicking things up a notch.
Is that 8n over to the 5th?
8n to the 5th, yes. just to make sure you're all headed the right way. We're going to take these exponents and distribute as multiplication to the exponents on the inside, including to the one you don't see right there. Don't forget to hit the constant numbers. I've got 5 squared, n to the 8/3, n to the 4/3, times n to the 4/3, 8 to the 1/3, n to the 5/3. So 5 squared is 25. I've got m to the 8/3 times m to the 4/3, which means I can be able to add these. I should do 8/3 plus 4/3 and make them 1. On the bottom, I have the 8 to the 1/3 is the cube root of 8, which is 2. And I have n to the 4/3, n to the 5/3, which means I can add those exponents too. This is going to give me 12/3 on top, which is 4. This is going to give me 9/3, which is 3. So n cubed on bottom. All right, let's go big. Let's do more.
Oh, sorry. Can you just come back with that one? I'm gonna take a picture.
Yeah.
Thank you. Sorry about that.
Okay. All good?
Oh, I'm sorry. Yeah. I took a picture. Sorry about that. Yeah.
Okay. All right. So this is a little bit different. What we're going to do is look at how to factor something that's weird. So I'm going to start with 12x squared minus 8x cubed. So one way of looking at it is going, okay, what is the exponent with the smallest value? And it's the square. I have an x squared is the smallest one. What I'm going to do is I'm going to divide this whole thing by x squared and multiply this whole thing by x squared. That kind of cancels out. But then we can do that subtraction thing. This is 12x squared over x squared. I'm breaking this up, which is something we would probably do a little bit faster. I'm going to put the x squared in front instead of in the back. And I can do the subtraction, 2 minus 2. And x to the 0 is just 1. So 12 times 1. Now, I didn't take into effect I can factor out a 4 as well. But this does a similar thing. I can divide each of these by 4 and multiply it by 4. And so I'm going to get 4x squared times 3 minus 2x. Okay, so let's kick that up to stuff that's weird. 28y to the negative 5th power plus 21y to the negative 2 power. I'm going to apply the same principle. Which exponent is the lowest? No.
-5.
Negative 5 is lower than negative 2. It's more negative. So I'm going to divide by y to the negative 5 on both. And we'll multiply by y to the negative 5. Does 28 and 21 have a number in common? 7. So we can do the same thing with the 7 and do it like that. So we've got 7y to the negative 5. 28 divided by 7 is 4. And I've got y to the negative 5. I'm going to do the subtraction thing. The top minus the bottom. And we can clean that up. Negative 5 minus negative 5 is 0. So y to the 0 is 1. So I've got 4 times 1 is 4. And I've got plus 3. Negative 2 minus negative 5 is negative 2 plus 5, so 3. 3y cubed. Okay. Go take it a little bit more awkward. Let's throw some fractions in it. Because the same principle applies. 18n to the 4/3 minus 12n to the 1/3. You teach at West Hills 1 semester. You get on their fucking list of text or call if there's a bomb threat or an emergency or something like that. And I've been getting phone calls and messages from them for 6 years. I ought to just look up how to take my shit off that list. Because they always come in pairs. There's the first one that says something's wrong, and then at least the one at the end when it says it's all clear. What is the lowest exponent on each of these? 1/3. So we're going to do n to the 1/3 on both of them. And what's the greatest common number between 18 and 12? 6. So I will have 6n to the 1/3 18 divided by 6 is 3. And I'm going to subtract exponents. So I get 6n to the 1/3, 3n to the 1, and when it's just 1, we don't leave it. 1/3 minus 1/3 is 0, so n to the 0 is 1. And that, if they all have a variable, like the examples we've just been doing, one of them should end up without the variable at all. That's the one, whichever one we took the smallest term from. This one had the 1/3. Notice it's the one that didn't end up with any variable. If you look back through all of them, the one with the smallest number is the one that didn't end with any variables. Let's kick that idea up a little bit. Same principle. These things are identical, so we can look at their exponent and go, which one is the lowest? -2/5 is lower, right? We're going to divide each of these by x plus 3 to the -2/5. And that puts an x plus 3 to the -2/5 on the outside. All right, so we can do the subtraction. I'm going to put that x plus 3 to the negative. This one I'm going to put to the front. I've got -2/5 minus -2/5. That becomes x plus 3 to the 0, which is 1. So don't let the x plus 3 throw you off and think it just stays there. Anything to the 0 power becomes 1. Then we had minus, and I'll subtract these. 3/5 minus -2/5 is 5/5, which is 1. So I'll have minus x plus 3. Finally, that cleans up a little bit. In here, I've got 1 minus x plus 3 like that. And I can distribute this negative to each of them. I've got 1 minus x minus 3. And the 1 minus 3 becomes -2. which means I could even factor it a little bit more. If I want to make it a little bit cleaner, both of these are negative. That's like -1 times x minus -1 times 2. I can factor the -1 out front, or just a negative sign. Okay, any questions on that? Ready to go big? I'm fucking running out of paper. What is this shit?
I'm sorry. It's hard to understand, but which one is the answer?
The one on the bottom.
The one, which one? The
one
Yeah,
on the
buddy.
bottom.
This one.
This was, I was just showing a little bit of work over here on the side.
Yeah. So okay.
I don't have fucking paper. What is this bullshit? I might need it in a second. That worked. Doesn't matter. One side isn't. Thank you. I can't believe I fucking ran out of paper. Look at this. I brought a stack. Look at the paper hogs. Burn down trees up here. All right. Don't make it hard. I'm gonna let you toy with it for a little while. It might be easier to not deal with negative exponents by getting rid of them. By like moving them to the other side of a fraction. Sure, everybody's doing it. All right. So the way we looked at this last episode, as in Tuesday's class, is we found the lowest common denominator of all the fractions on the inside. So what is that? I've got an x, I've got a y, I've got an x squared and a y squared. If I do my little column thing, I've got an x there, I've got a y here. X squared, I put one x there and I still have another x. And y squared, I have one y and I need another column for another y. So when I bring these all down, I've got xy, which is x squared, y squared. So what we did is we multiplied top and bottom by x squared, y squared. And we distributed that. So rather than try to, do it all at once, I'm just gonna distribute it and write it. The x squared, y squared gets multiplied by the numerator. All right, let's start cleaning up. X squared, y squared, if I divide by that x, I can do This is x squared over x to the first power, that right there, the x part of it. So I can do x to the 2 minus 1. So that'd be leaving me with an x. So I'm going to have xy squared, because I didn't do anything with the y squared part. And the same thing happens with the y squared and the y. I can cancel out a y. I'm going to be left with an x squared y. On the bottom here, the x squareds cancel. And I'm just left with y squared. On this one, the y squareds cancel, and I'm left with x squared. Oops. Now we got to see if anything cancels, so we got to factor some more. What factors out of the top? An xy, right? If I take out an xy, I should be left with a y plus an x. Does the bottom factor? Yes or no? This is, remember we did the a squared minus b squared? I can do this as y minus x times y plus x. Look at this shit, like magic. So y plus x goes away, and we are left with xy over y minus x. Can I cancel out a y? I got a y on top and bottom. Can I cancel out a y? Why not? We can't cancel them because they're not multiplied together. This negative in here is fucking shit up. So that's where we're stuck. Ready for more? All right, so we did a lot with fun exponent stuff there. Let's do some more stuff with radicals. Let's find the cube root of 27. If you already know it, you're good to go. We can always factor the 27. 27 is 9 times 3. 9 is 3 times 3. So I can rewrite this as the cube root. I've got 3 showing up 3 times. So I've got 3 to the 3rd power. So if you recognize right away, the index out here matches the exponent, we can just jump straight to, they cancel each other out and I have a 3. Otherwise, rewrite it as 3 to the 3rd power times 1/3. The exponent, the radical part, the cube root like that turns into the 1/3 right there. So from that point, we can take the fraction or the exponents and multiply them. And 3 times 1/3 is 1. And we get that. Now, if you're not sure what this is, just start peeling out tens. I can divide this by 10.
That's 10 to the 10th power, to the 4th power, I mean.
It will get to, well, yeah, it'll be 10 to the 4th power. But if you don't recognize that, just keep pulling out, dividing by 10. So I was able to divide out 10 4 times. I can write that as 10 to the 4th power inside there.
Because of how you write your zeros, I thought the middle 0 was an 8.
That one?
Yeah.
It does kind of look like an 8. Yeah, when I do 3 zeros together, it's always like that. That's just, I don't know. It's probably something I picked up from my mom. So we got negative, and I can do that 4th root outside. We can see they cancel. Or you can write this as 10 to the 4th power times 1/4. And the 4 and the 1/4 cancel. I've got negative 10 to the 1st power, which is just negative 10. And sure, this is something you can throw in a calculator, but it kind of defeats the purpose of, because it's not always numbers that we're doing. Sometimes it's variables and stuff like that. But it's worth exploring a way to try this. I don't know what 216 breaks down to, so I'm just going to start dividing my numbers that I know works. 216 is an even number, so I know I can divide 2 into it. If I do 2, I'm going to get 108. And that's again even, so I can pull out another 2, and I get 54. Again, that's even, and I get 2 and 27. And we already did this one earlier. We saw that was 3 cubed. So I've got 2, 2, 2, which is 2 cubed. I've got 2 cubed times 3 cubed. And I can leave them like that. Since this number out here is a cube, and these are cubes, I can put that negative in with one of them. I can say that's negative 2 cubed, and then 3 cubed. And I got a 3 on the outside. I've got 3 as exponents on the inside. That shit kind of all wipes out. I'm left with negative 2 times 3, which is negative 6. So apparently, negative 216 was negative 6 cubed. But I didn't know 6 cubed offhand. I suspect you guys didn't either, unless you guys had some better this shit than me. It's possible. I meet people better than me at math all the time. Not all the time, but often enough. Didn't I do that one already? No, I didn't. Ready for more? Let's do negative 64 to the 2/3. When you're given something like this, there's 2 ways of going about it. I can do negative 64 squared and then cubed, or 1/3. Or I can do the negative 64 to the 1/3 and then squared. I recommend checking this route first, because it's easier to find a cube root of a smaller number than it is of a much larger number. Yeah. It's 1/3 because the 2's out here.
Oh.
That should be 1 right there too. So if you're not sure, again, break it down. 64 divided by 2 is 32. And 32 divided by 2 is 16. And now I'm getting a number I recognize. I know 16 is 4 squared. And I got 2 times 2, that's also a 4. So I really got 4 cubed in there. So I could say negative 4 cubed to the 1/3 to the 2/3, or to the second power. The 3 and the 1/3 cancel out. I'm just left with negative 4 squared. And negative 4 squared is 16. Next problem. Go ahead and try your hand at that, and we'll do it together in a second. We're going to work on radicals one more day. So I need to adjust the homework schedule. I had originally planned on being done by today, but I've been trying to give you guys more time in class to practice. Because I think it's more helpful and slow me down just a little bit, but that's okay. I think getting these fundamentals down now will make it you guys do better overall. Hopefully, on this problem, you guys recognize that the negative is not part of it. So this is 121 to the 3/2. And again, I'm going to do that where I do the fraction part first. So I'm going to have 121. I'll put the 3 outside. And I'll have 1/2 on the inside or 1/2 of the square root. And square root of 121 is 11. And that should give you negative 1,331. Yeah.
I got negative 1,331, but I put the negative inside of the and do on the outside.
So if you put it on the inside like this, where did you go from there? What was the next thing?
I went and I put the 1/2 on the 121.
Like that? Okay, so when we do that, we have the square root of a negative number. The square root of a negative number is actually going to be a complex number. For now, it doesn't exist in the real world. So that would have given you 11i on the inside.
I just really disregarded the whole
right
of the negative and just went straight down and just kept the negative on negative.
Right, and so that's a learning thing.
But it worked. That's so weird. I got negative 1,000.
But you probably said that was negative 11, right?
Yeah.
It's not. Do square root of negative 121 in your calculator. You just had 2 mistakes that cancel each other out. That's all. Which is going to be bad luck if it happens on the test. Because it's not, unless I may not notice. Because oftentimes I will look at the answer, and if just skimming the problem looks like you did it right, I move on. If at that point someone has a history of making mistakes, I might pay more attention. And it may go unnoticed, but if I catch it, then it's like you did 2 things wrong. So I gotta mark off both of them. Because the answer is only worth like a small percentage of each thing on each test or each question. All right, let's call it a day. We will do more of this on Monday. Tuesday. Okay, Tuesday. Let's do it on Tuesday. Tuesday sounds like a good day. Tuesday sounds like a better day than Monday. Because my Monday classes were pretty pissed off. I don't think they'd keep up. I will be out of town this weekend, so the Starbucks thing, no one's attended it yet. I won't be there this weekend.
We'll have